and welcome to space, here from the observatory of the Côte d'Azur in the south of France. This month we're talking about asteroids, big lumps of rock and metal speeding through space. We're here to learn about the missions that are trying to study them and find out whether we can deflect one of these asteroids should it be on a collision course with planet Earth. Asteroids have the potential to cause a catastrophe. A small asteroid could wipe out an entire city, while a large one could mean the end for us all. It's a threat we're aware of, and which experts like Patrick Michel from the Observatory of the Côte d'Azur are working to overcome.
An asteroid is a small rock, which is one of the bricks left over from the formation of our planets. Some of them are dangerous because although they're out there between Mars and Jupiter, in what we call the asteroid belt, there are some that have a trajectory across that of Earth, and those are the ones that pose a threat.
It's a threat that's limited. A sizable asteroid strike only happens every 10,000 years or more, but it's a threat to be taken seriously.
Even if the frequency of impact is very low, like the probability of winning the lottery is very low, but there are those that do win.
With that threat looming above us, the world's space agencies are swinging into action. Just recently, 2 missions, one American and one Japanese, set off to visit asteroids and bring back samples to be studied on Earth. Now, ESA and NASA are planning to try something that's never been tried before in a joint project called AIDA.
It's tumbling, right? Yeah, tumbling. That's why, I mean, it's periodic, but it's not. AIDA, I think, is the most audacious mission after Rosetta. It's a mission where we plan to test for real a mitigation technique called kinetic impactor to actually test if we can deflect asteroids. This is the main objective of this international cooperation between ESA and NASA.
The mission outline goes like this. ESA's AIM spacecraft launches in the year 2020 to an asteroid system called Didymos, in which a large asteroid is orbited by a small asteroid dubbed Didymoon. It surveys that moon, and then 6 months later, NASA's DART spacecraft arrives and smashes into Didymoon, while AIM records what happens.
The impact will be spectacular. DART will arrive at about 6 kilometers per second. AIM will be at about 100 kilometers distance to make sure we're away. The difference that DART will make is to change the speed of the moon around the main asteroid by about 0.5 millimeter per second. Now, this is very small, but it will generate a change in time of about 10 minutes over 11 hours, and this we can measure very accurately.
Before that can happen, there's a lot to learn. Here at ESA's Technical Centre in the Netherlands, the engineers are simulating the scene that the AIM spacecraft will encounter when it arrives at the asteroid. Right now, we know that the small Didymoon orbits the larger asteroid, but we don't know much else.
We have a rough idea of how it looks like, and from what we've observed, this is how we think it more or less looks like, but the operating work is more or less. We're not entirely sure, and we won't be sure until we get there.
Irene uses this facility to set up the spacecraft's camera to be ready to do a thorough job of observing the impact.
We can shoot different scenes with darker asteroids, lighter asteroids, a very rocky surface, a very smooth surface, a combination of both, a darker moon, a lighter main body. What AIM will do after this impact has taken place is going to take more images and is going to see what happened, what it looked like before the impact, what it looked like after the impact, and see, how much has this orbit around the big asteroid changed? How much have we displaced the little moon?
This double asteroid system was chosen because it comes close to Earth but poses no threat to our planet. However, objects the same size as the little moon could mean trouble if they're heading in our direction.
Didymoon is about 163 meters in diameter, and this is a very interesting size because it's representative of a type of asteroid that if it were to hit the Earth would generate casualties independently of the impact point. So if it's in the middle of the ocean, it would generate a tsunami. If it's on any place on the surface, on the ground, it will reach habitated areas. So it's a very important type of asteroid.
Back in Nice, and asteroid expert Patrick Michel underlines that this mission is a true experiment because we really don't know if we can deflect an asteroid.
The response of an object to an impact depends a great deal on its internal structure. If my target is a metal bar, the response won't be the same as if my target is a sponge. So, thanks to the AIM spacecraft, we know exactly what this object is made from, and we can validate all the digital simulations of the impact and better interpret the results of it.
What follows, it's hoped, will be a whole raft of asteroid deflection missions, perfecting our technique so we're ready when a true menace appears on the horizon.
Asteroids are a genuine threat to consider because even if we don't have to worry in the short term, it's the only threat from nature that we can predict and against which we can do something.
Et contre lequel on peut faire quelque chose.